Hey guys, welcome to the fifth episode of the AI series. In today's video, we're going to take a look at datasets, features, and labels. So let's get straight into it. We talked a lot about models learning to fit to the labels by changing their settings, but we never stopped to look at the data itself. And the data is where most of the real work and most of the real failures actually live. So here's the truth at the bottom of every machine learning project. From a spam filter to a self-driving car, a table, rows, columns, numbers is a must. And we must learn to read this as a shape, and the rest of the field of machine learning will stop feeling like absolute magic. Now, there are ever only two kinds of columns in machine learning: the ones you measure and the ones you feed in, which are the sizes, bedrooms, and the age of a house, which are the features, which are collected together and written as a capital X. The single column you're trying to predict is the label, written as a lowercase y. Inputs in blue and the answer is in yellow. The same blue and yellow we've used since the very first video. And notice that yellow label column only exists because this is supervised learning. Strip it away and you got an unsupervised learning problem instead, which is a whole module of its own later on. Now the move that unlocks everything. Take one row, ignore the price for a moment, and just focus on the features, which is the X column. Two features means two numbers, and two numbers are coordinates. So this row isn't really a row. It's a point in a graph floating on one exact spot in a plane. Do it for every row and watch the table dissolve as each row lifts off and becomes a point on a graph until the whole spreadsheet has turned into a cloud drifting in space with just a bunch of points. This space, where one axis per feature, is called the feature space. And it's where every algorithm we'll ever build does its real work. But the Y column, which is our label, hasn't vanished yet. Let's put it back in as color. From now on, whenever I say a model learns, I want you to picture exactly this: drawing curves and borders through a cloud of colored points. But real datasets aren't all tidy numbers. A column might say city, New York, London, Tokyo, Dubai, or color red, blue, green. Those are categorical features. And of course, a model cannot multiply Tokyo by a number or by a weight or anything numerical. It only understands numbers, so we translate. The naive fix is when we say Dubai is equal to 1, New York is equal to 2, London is equal to 3, is a trap because it secretly tells the model that New York is 2 times Dubai, and it makes weird confusions like that, which is absolute nonsense. The honest fix is called one hot encoding. Turn one categorical column into several yes or no columns, saying, okay, is this Dubai? Is it London? Is it Tokyo? And with each clean 1 or 0, 1 representing true and 0 representing false. It's a small step, but if we skip it, our model quietly learns relationships that were never there, and it can screw up our entire result later. Here's one that troubles almost every beginner, and it hides in plain sight. Look at our features. Size ranges from 30 to 500 square meters, while bedrooms range from 1 to 5. Same table and widely different scales. Why should that matter? Because many algorithms measure distance or take steps through a feature space, and a feature with big raw numbers will dominate one with small ones purely because of its units. Not because it's more important, A difference of 200 square meters swamps a difference of 2 bedrooms. Even if bedrooms matter more, the fix is to rescale every feature onto a common footing or a common unit, squeezing everything into a 0 to 1 range, or recentering it to have a standard unit. It feels like a boring job, but it's the difference between an algorithm that converges quickly and one that crawls, or worse, quietly trusts the wrong feature space. If one of your features were measured in millimeters instead of meters, should the answers change? Well, that's up to you, and it's your job to find out the answer to that question. Which brings us to the rule that quietly governs this entire field: garbage in and garbage out. A brilliant algorithm fed messy, biased, or badly chosen features will lose every time to a simple algorithm fed clean and thoughtful ones. The feature places the points, the labels color them, and the model only ever draws the geometry in between. So, a huge share of machine learning isn't just writing fancy algorithms at all. It's choosing, cleaning, and encoding and scaling the columns of this humble table. Get that right, and everything we build on top of it has a fighting chance. If this video helped you understand what are datasets, features, and labels, then make sure to subscribe and hit the like button for more videos like this.